Good morning, Mozilla. I'm really pleased today to introduce Timoni West. She's going to be talking about spatial computing. She's from Unity. My name is Ansem Hook. I work with the Mozilla Mixed Reality Research Group. And before I introduce her, I just want to mention one little story. I just was looking back at the kind of the chronicles of the transition of the internet over the last 20 years. And if you recall, the iPhone came out 11 years ago in the summer. And it's amazing if you think about that journey. You know, before that, there's kind of like the pre-iPhone era and the pre-mobile phone era. And then you kind of come into this period where there's a sudden change over the last decade. And it feels like we're on the edge of that kind of transition again. And so I just want to suggest that, you know, it's hard for us to see the future, but when we have guests like this who can help us kind of understand that and see those transitions, I think it's wise to kind of listen carefully and see what they have to say. And I'd like to bring you up and let you introduce yourself in more detail.
Sure.
Yep.
Thanks. Hi, everyone. Hi, Mozilla people out there. Nice. So glad to be here. So I'm Timoni West, and I'm the Director of XR, AR, VR, MR research at Unity Labs. And today I'm going to be talking about the tools that we're making for spatial computing, and also a little bit about how we're thinking about the problem space in general, in part to start a conversation that I think will continue again over the next decade and beyond. So, yep, I work at Unity. How many people here have heard of Unity or know it? Oh, wow, everybody. I'll go through this part fast then. Okay, so obviously it's been used most famously, I think one of the most famous games is Pokemon Go. Flappy Bird is pretty successful as well. Firewatch is an absolute gem of a game if you haven't played it before. But it's also been used to make really cool scientific visualizations, things like the CERN visualization. It's been used to do visualizations for JPL and NASA, and it's also been used for things like teaching autonomous vehicles how to drive in 3D worlds. So lots of different cool use cases, generating worlds of tomorrow and visualizing what that will look like, and personal favorite right now, Florence, which is a great little indie game that I highly recommend. Okay, so let's see, it's not skipping ahead. Oh, right. We're also delving into higher fidelity real-time rendering, like Pixar quality. And this is actually a shot from inside Unity. So we're really trying to push the grounds on what's possible and what you can achieve on your computer in real time without having to render out to farms. And this is what Unity looks like, but you're all aware of that. Everyone raised their hand in the room. So, okay. So I work on the labs team, and these are the big things that we're focusing on for this year. I'm going to focus specifically on XR, but there are a variety of different research areas. Ontological metadata for semantic creation. This is something we'd like to standardize with different groups as well. Authoring tools for spatial computing, that's my area. Graphics research, which I touched on a little bit. Human capture and rendering as well, specifically for avatars and for very high-end movies. And then artificial intelligence, which is especially important for things like non-player characters in games, so you don't have to animate or visualize everything yourself. Behavior planning, and then animation as well. Okay, so here's a little loop of all the things we've been working on for 2018. Okay, I realized I misspoke. That's not our projects for this year. Those are all our projects up through this year. So now we're going to talk about the projects that we're working on for this year. First, I want to start with Editor XR. How many, has anyone ever downloaded and tried Editor XR? It's an open source extension on GitHub. Okay, cool. Thank you. I appreciate that. Okay, so when we started Editor XR, we wanted to figure out how to get an interface that most people are used to, which is a series of hotkeys trying to move in 3 dimensions on a 2-dimensional screen, and translate that effectively to what we call native 3D, so VR in VR, or 3D in 3D being in VR. It ended up being extraordinarily challenging because when it comes to Unity, you can't have the limits that you can have in VR games. You don't have a system of limitations the way you can when you're actually making a VR experience. So we had to make sure that everything that you could do in regular Unity, you could also do in VR Unity. And you can move things that are the size of a pin or the size of a mountain, and you can move them miles in Unity. You cannot do any of these things in real life. So trying to figure out how to effectively let people do what they want was a significant challenge. I'm just going to talk through a couple of the different ways we tried to attack this. So first of all, selection. We realized we needed a bunch of different ways for you to be able to select. So we have the kind of standard gizmo that you would expect from any 3D tool to allow you to move, say, like on a plane or move along an axis or rotate in specific ways. But we also had to have things like, you see here, this is a pretty significant lazy follow from the actual ray, because the further away you get from the hand, the further the larger the angle is, right? That you're moving objects. So we realized that if we kept it 1-to-1, basically you were going to be moving objects really far away very quickly, especially when you get to glancing angles. So we had to do a lot of research and a lot of back and forth about what actually feels good, like what does the user intend to do versus what they actually told the computer to do. That's really the problem in the end, because when it comes to virtual reality, you feel like you're in the real world, but you're not. You're in a fake world that is talking to a computer, and that is, I think, the core of the problem. Okay, let's see. That gives you a sense of that. I want to talk a little bit about here. We ended up having to have a variety of different snapping techniques as well, because it turns out if you want to put something on the ground, you might want to put it next to it. You might want to have it rotate. You might want to have it rotate in different ways, like, for example, along a plane, or maybe when it turns, you want it to go like this, or maybe you want it to not turn and stay on the same rotation. So we have a variety of different ways that people can actually snap along different faces. Another big thing that we couldn't do here is we can't add colliders to the scene, so we had to come up with a different way of extrapolating all of the surface information for every object. It was really interesting. So you can see here that things are moving in the little line of objects here is snapping in a variety of different ways, but it might not be the way that you wanted it to snap. But it is the way the computer thinks it should snap. Smart guides are hard, even for 2D, but when it comes to 3D, they get really tricky. All right, here's another example of a new interface that we made for virtual reality. So this is called the mini world, and you can do pretty crazy things with the mini world. You can have multiple mini worlds. You can scale them to any size. You can also scale the window that they're in to any size, and then you can move objects in and out of the mini world into other mini worlds or into the life-size world that you're in. And the reason why we felt this was important is because sometimes inherently you kind of want things at arm's length at all time when you're creating, but you also want to see what you're doing at scale. And you could just scale the world up and down, and this is a very popular technique. You can do that in Editor VR as well. But we also thought there was something really useful about being able to preview and visualize at the same time. And it's also just handy to have a way to, say, go a mile away, grab a tree you wanted, and bring that tree right next to you. So that's what the mini world can do. One key thing to mention here is about virtual reality tools as well, is that for a lot of the creation tools, you don't have like a ton to interact with. You have the creation that you're working on, and then you have the UI that supports that creation. So if you're in Tilt Brush, you've got a bunch of brush strokes that you've made that are all of a specific style, and then you have UI that you point to. But when you're in a 3-dimensional world, your entire world is also your creation, but then you also have the UI which fits into the world itself. And we realize that you're going to need to tell the computer that you want to interact with those things differently. If I want to pick up an object that's in the game, it has to be interacted with a little bit differently than the UI in the scene, or I'll accidentally be picking the UI when I meant to pick the game object, and vice versa. So the way you select the UI in Editor VR is with the secondary trigger or with the grips instead, just to make sure that if you're reaching out to grab something, you're actually grabbing the right thing. So you can actually kind of ignore the UI when you want to, which is how we work with 2D apps. But when it's all 3D and it's all in front of your face and it's all right here, it's a little bit harder to differentiate between the two. Okay, so you might have noticed that the UI right now is very tied to the hand, so you guys are getting the first sneak peek of a new spatial UI system that Dylan Urquidi has been working on for a while, where you can actually look wherever you want to and have the UI pull up. So we have a hotkey, basically, if you hold down the secondary trigger right now, you can switch between all of the different tools and all the different selection mechanics on the fly. And the one cool thing about this particular type of spatial system, so you'll see here, wherever he looks, he can bring up that menu. He'll just pull, left or right, whichever direction he wants to go, and then it disappears. It has a lazy follow, so if you're looking in a different direction, it'll kind of follow behind you, and as soon as you release the trigger, it goes away. And we think this is really cool because tying the UI to the hands means that you will constantly be shifting between the thing that you're interested in and the thing that you are trying to do. And we're trying to bring those a little bit closer together with this system. Did everyone get a sense of that? I can repeat it quick because I started talking. People got it? Okay, cool. All right. So that's Editor XR. I definitely encourage you to try it out. Again, shout out to you for actually downloading and trying it out. It's available on GitHub. It's open source, and we do take contributions back from the community as well. And we're also going to be releasing a runtime version, so you can take anything that we have in Editor XR, all the selection modes. We have 6 different ways of locomoting, for example, and put them in your own runtime, which I think is very exciting. So that's Editor XR. All right, now we're going to talk about our next project, which we just announced last month in June at Unite Berlin. This is Project Mars. Let's talk about why we're working on Project Mars. Okay. So we wanted to tackle augmented reality for 2018. We wanted to tackle it both for mixed reality, for augmented reality, for mobile, and for the future of wearable devices when we're all interacting with the space and computers know what we're doing. But what we quickly realized is that the way you author for augmented reality is bonkers. It is completely different than the way you author for anything else. Because when you author for a digital world, you are authoring in a space where you know where everything is. And if you author for a very specific place, I say authoring, we just use that term a lot internally, but you could say creating. If you're creating like something for architecture or an art installation, you also have a very strong sense of where the space is and you can work within that space. But in this mixed digital world that we are creating, or the future of spatial computing, you need your application to run really well in any room. And that is just an insane task, an insane challenge. And your experience has to be robust, it has to be flexible, it has to allow you to say, like, put the Hyrule Castle here, but if there isn't enough space, put it there, and if there isn't enough space, then put it here. You have to have these really smart fallbacks that can work anywhere you want. Okay, so the way that you can author in the space involves a lot of how computers can make sense of the space as well. And from device to device, this is very different right now, and I have a very big chart to show you in a few minutes. So you can do it in a variety of ways. Obviously, there's LiDAR, there's cameras. Some are dependent on software, some are dependent on hardware, some are specific algorithms that are very tied to the platform. But these are all basically the main ways that any given augmented or mixed reality device would make sense of the world and feed that back in to give you basically the base for your experience. Thank you, Matt Schoen, for making this chart. This was a really big chart to make. This is kind of what's out there right now on the software side. So you got Vuforia, 60AI, placed on Solera. You'll see Visage, those are face tracking, Google Mobile Vision, Apple Vision, Wrench AI, body tracking, Leap Motion, OpenCV, DLib, and then somewhere out there in the future is a software that can actually take all of these things and run with it. But for right now, you can see that it's a fairly scattered space. Same is true on the hardware side. And I know this is a combination of hardware and software, so bear with me here. But these are all the ones that actually are tied to a specific hardware platform. So you've got everything from your iPhone and your Android device all the way down to Gear VR. And almost all of them have some sense of world space. Maybe, the mobile VR, probably the worst of the bunch. But as you can see, it's incredibly fractured. There are really significant holes here, right, in the space about how these devices can make sense of the world. Also true that the world data that you get right now is not usually available when you're making the experience. It's not usually available in Unity or on your PC. It's usually just available at runtime when you're actually running the device. Like if you want to get plain information from an iPhone today, you have to turn on your iPhone, open up your camera, and get a recording. And if you want to put that back into Unity or another application to actually author your experience, you have to just copy it. You don't get it for free, and you definitely don't get it on your PC. This is something that I've been really advocating for over the last 6 months since we started this project. People need to understand that computers need to be making sense of the world all the time, not just when you're a consumer, but also when you are an author or a developer of the experience. Machine learning, too, is also very tied to specific hardware stacks right now, which is, frankly, just kind of a pain in the ass if you're trying to make an experience that can run across multiple devices. So just something that it means it can go faster. It means that we can make more sense of the world, but it also means that you're much more tied to hardware that's intelligent one place, and then if you try to make it for another platform, you're kind of out of luck. Okay, so again, our responsibility as Unity is to let developers make experiences that are flexible, that are robust, that can work, I guess, in any environment. You need to be able to test a lot, and you need to be able to test without having to go to the place where your app might run. You can't go into everyone's bedroom for your bedroom application, right, and test. Well, you can. You could try that. It would take a really long time, and you'd be creepy. It would be terrible, right? So we need ways for people to be able to simulate testing in the app, or sorry, in Unity. So the way we started thinking about the problem is that you might have nothing, and we'll start off with the base layers, the most basic things about the space, and we'll have a series of queries around the space that allow you to kind of extrapolate up from the experience you want to make and step by step make more sense of the space. So this was an early prototype we did. You know, I think I might be missing a slide here. My apologies. Let me go back to here quickly. Okay. All right. Nope. Oh no. Animation again. Okay. Cool. All right. I want to explain a little bit more about this right now because I think I missed that slide in the middle here. I want to explain what you're looking at. So on the left-hand side, we have an entirely new view that wasn't in Unity before. We call this the simulation view, and this is where you can test your application, and you can hit reload and reload a bunch of different templates. You can bring in recorded information that you have, either from your iPhone or if you have a mesh, from a HoloLens, whatever kind of information that you have about the world. It could be your face, it could be a video, like Lens and AR Studio. You can put this in the simulation view and then just see how your application is going to look in a variety of spaces. On the right-hand side, my right-hand side, is the scene view that everyone knows and loves. But it has some new gizmos that are specifically designed for letting you describe how you want this object to live in the world. So down at the bottom, you can see this has a height parameter. But we also have other components like proximity, like elevation, plane size. If you have an image marker, you can attach that to that. You can attach a variety of components to any given object to say, okay, if I'm in a room that is 8 feet by 10 feet, find the highest, largest plane and put Hyrule Castle there, right? And then below that, have that be the plane, populate that with grass, and then have baddies kind of going all around on the plane, right? And that should be able to work in any room that you have enough data to be able to place those objects in the space. And you can work indoors, you can work outdoors. It just depends on how much information you have. One other key thing about this is that we're designing it to take in as much information as we possibly can. We've already done some work, so it works with ARKit and Core. We were talking earlier about 60 AI, Mapbox integrations, any sort of world information. It doesn't have to be AR specific, but something that will help your experience run. You can integrate it with Mars and use that to author against. So for example, here's a flow where you have an image marker, and when you find the image, you have whatever happened. Maybe information comes up, maybe it starts to animate whatever you want. Flows for geomarkers, and then being able to have geofences around specific geomarkers. So when you see what is that, the Brandenburg Gate? Yeah, then you have, for some reason, a helicopter in front of it. Not sure about that wireframe, but anyway, that's the idea. And of course, you might have nothing. Like, you might have absolutely no idea what's going on in the space, and you still need your app to run. I have I have an app on my phone, an AR app, that is looking for a vertical plane of a size that I can't fucking find. I've never been able to run this app before. I don't know what it does. Periodically, I will open it up and be like, okay, someday I'll learn. So what we want you to do is be able to just check against all of the data, every single piece of data that you possibly can have. And if there isn't any information, figure out what is the lowest common denominator, is the smallest thing that you can possibly get your app to do. That's a key part of authoring, really, for spatial computing in a robust way. Let's see. Okay, so the way that we set this up is that you decide a series of conditions that you want it to have, right? Elevation, proximity, all of the things that I mentioned. And then we run a query on this. So we have something called a Mars entity. And the Mars entity is not an object. It's not a game object. It's not something that exists in a real world. It's really just the result of those conditions. Sometimes we call it an AR object. But it's this thing that is kind of just the answer to a question, or it exists like, it's kind of one of those nebulous, like, it's not a real thing, and it's not even really a thing, but it still has results. And it looks like this. So for example, you have here, we say that we need to have a physical object that this is attached to, the elevation condition, distance condition, and the plane size condition. And that once all of these conditions are met, we will perform whatever it is that you want to have happen, like maybe those fireworks, or maybe a dragon comes out of the ground, whatever it is that you want to make. So that's the basics of Mars. The key point here, I think one of the key takeaways is that the scene view itself now has a completely different meaning. You used to use the scene view, or like a traditional space, to lay out your world. And with Mars, that's no longer the case. That's just where you tell the computer what you want it to do in order to match the world and then have something happen as a result. And it's really backwards. It is not how people are used to thinking about world building or game building at all. So it's a strange new paradigm, and I'm very curious to see if people go with this or if we're going to have to rethink the whole thing in 2 years and start over again. But this is the way we thought that it made the most sense to kind of remove the objects from their position in the computer and only think about the positions of the object in the world itself. So in that sense, mixed reality authoring is pretty significantly different than traditional 3D authoring. The scene is just an abstract set of conditions. And another big thing is that world scaling is really important. You have to be clear about how your content scales to the world, but you can't scale the content itself, so we have to scale the camera. Again, a completely different way of thinking about how you author. Right, and again, in the editor, we want to have some way of you previewing how it will lay out, but the position of the object in the program doesn't really matter at all. And that's just been something we weren't expecting when we started on this journey, but now seems to be a pretty fundamental way of thinking about spatial computing across the board. In other words, everything about how we interact with computers now kind of needs to be rethought. And that's just for 2D. Like, this is just for an app that is like 12 years old, right? These are paradigms that people are used to. But I want to talk a little bit about now, like, the future of spatial computing and the types of things that we have also come up against when we think about all the use cases that we want to have people be able to support. So today, I would consider email almost the de facto passport of the internet. If I want to share something with you, if I want to be your friend, if I want to log into an account, if I want to verify my identity, it might be text message, that's increasing over time, but right now email is the way that you transmit a lot of information. And that will have to need to be rethought, because when we all have AR glasses on and we want to share things with each other, we're going to want something a lot closer to a browser, which I hear you guys are good at. Sharing things across platforms in general, right? Even if you have a browser and we're all in the same browser, well, we might be on different browsers, right? We might be on the same sort of internet of the future, but we might be choosing different browsers. Where permissions are, we'll go over that more in a bit. How do you discover apps when apps kind of live everywhere in the real world? That's a big question, right? When things are minimized, you don't want them to get in your way, and you don't want to be visually overloading, but you do have to find them, right? I'll talk a bit more about how you need to tell computers things that we never articulate normally. That's a weird one. You have to be very specific about what you want when your computer can be in your face. And then modalities and inputs, we'll touch on that a little bit. That's actually one of my favorite topics, so if you want my 100-slide talk on that, I'm happy to share that with anybody. But we'll just touch on it a little bit in this time. Okay, so we need to tell computers things that we never articulate or normally even think about. First, let's talk a little bit about how we talk to computers today. So I'm going to talk about modalities and affordances, inputs and feedback. Modalities is just the way in which you talk to the computer or the computer talks to you. Visual, physical, or audio are the big ones. Affordances are how you know what you can do. Inputs is how you do it, you know, the way that you interact with the computer. And the feedback is obviously the confirmation. So visual, poses, graphics, text, UI, animations, and screens. These are all the ways that we interact, certainly with our phones and our iPads, a little bit less so with our computer where we have more physical feedback, but you know, visual is the big one. Auditory, usually used for feedback loops. This one you can opt out of, so it's a little bit less dependable than the visual stuff. And then obviously physical, all the keyboards and mice and game controllers of the world. There are also now a variety of new inputs that are very exciting, often biometric based, and they are kind of curious compared to the other types of inputs in that they're largely unconscious, and actually, if you think about them, the data gets wonky. So it's actually better if you're not aware of the fact that, you know, your Magic Leap or HoloLens can track your heart rate through the blood vessels in your eyes, right? Because that will actually kind of fuck it up, and maybe your heart will start racing, and you're like, oh God, I'm being watched by the internet. Yeah. But these are all cool, I think, and worth noting because as a primary input, not so great. And I'll include hand tracking in this to a certain degree. But in terms of informing intent and allowing things to kind of subtly interact with you, all of these are solid gold. Especially the unconscious limb movement is a really cool one because then you can do things like track hand trajectory to infer intent on an object that's far away. If you triangulate that with your eye gaze, for example, you can get a really good sense of what it is the user is actually trying to go for, which is pretty cool. So going back to sort of the big ones, visual, there's different stages in how the user is going to interact with anything. Okay, so when it comes to learning how to do things, visual is by far the best. It is the way you can get across the fastest amount of information in the fastest amount of time. It means you can be really precise, you can use words, you can point with big arrows. As an input, it's pretty poor. There really is no visual input per se, but you know, if you only have your hand, it's just not as fast. There's no muscle memory there. And for feedback confirmation, it's good. It's pretty average. Audio is good for affordances. You know, like when you're fighting someone and you hear like the cry of the dragon coming towards you to fight. You're like, okay, we're going into fight mode. The music's gonna change. You know, as an action, I'm gonna say it's good, and I'm just saying this because I really want voice to be better than it is today. Right now, it's not that great, but it will be good. It will definitely be good. And for feedback confirmation, it's actually really excellent because getting that quick little ding or beep or trigger, whatever, that's great. So physical inputs are my favorite, but physical inputs are the hardest to learn from the beginning. When you are learning to play a saxophone, when you are learning to type, when you are learning to play any given game, it takes a while and a series of tutorials and a series of feedback loops before you can move that out of the prefrontal cortex and into muscle memory. But once you've got it, that's when the magic really starts to happen, and that's when you can start being really fast and really precise and fairly error-free, right? So as an input, it's excellent. Physical buttons, everyone loves those. And as feedback confirmation, haptic feedback tends to be good. It'll probably be better if we nail haptic fidelity, but for now it's just usually like a rumble or something. So touching on the point I was saying earlier about physical inputs being better later, if you're in mastery mode, visual affordances are not as good as physical affordances. At some point, if you learn to play the piano, you don't need to look at your hands anymore. The same is true if you're typing. And this, I think, is something that I'm a little concerned about when I see the controllers for immersive stuff today, because they tend to be a single button, and it's very heavily focused on having visual UI for training purposes, but it's ignoring it, and that's great. That's great because most people haven't used VR. We don't really even have augmented reality headsets on the market. So as long as everyone's in that beginner stage, fine, a single button is cool. But when we get into the future and we want to have everyone wearing their mixed reality headsets 12 hours a day, we need to have robust inputs that allow us to move really quickly and again, be error-free. So I made this little graphic just so you can start to think about when you're thinking about a modality in general, what is the normal way that the person interacts with the computer? What does the feedback cycle look like? And I did a little version of this with a typical game for a console, and let's say you have a controller. So at the beginning, you have the affordance and the discovery. Most of this is going to be visual with some audio, like you see the bad guy, or you see something that's like, hit the B button, right? And then with the physical, to actually hit the B button. And then your feedback loop will be maybe a lot of audio, you hear the swing of the sword, a little bit of visual feedback, you see the sword, and maybe even some physical feedback if you hit something. But these are the key things that you need to know about inputs across the board. This is how inputs start to become popular. They are cheap, they are reliable, they behave consistently. The mouse had to drop by $350 before it started becoming ubiquitous in 1984. It went from a $400 Logitech / Microsoft mouse to a $35 mouse that came with the Macintosh. They let users do things with acceptable error rates. And I want to touch on this a little bit because the amount I make typos on my iPhone is pretty much unacceptable. So all my emails have gotten much, much shorter. And that's okay because they're honing in on spell check to make that error rate fairly acceptable. But if I have something important to say, or if I need to write a really long email or a document, I will wait until I get back to my keyboard and I will write it there instead. Obviously, they have to be physically comfortable. I have this amazing essay from like 1983 where this guy spends 16,000 words just bitching about all the different game controllers at the time and how bad they were and how he got blisters from them. That was an error. And then finally, you need software that supports the input well. I've seen many cool one-off Kickstarters where people made better keyboards or better mice or better styluses or whatever, but if there's no software that actually supports what it is the hardware can do, it's always just going to kind of be a niche thing. Okay, so that is how we talk to computers today. Now let's go to the flip side. So again, we're going to need to tell computers things that we never normally articulate or think about. For example, we're going to need to tell them about our homes. What is okay to do in our house? What's okay to do in our bedroom, in our child's bedroom, for example? We have some of this today, but it's going to start to expand out to the entire world. So I'm going to touch a little bit on how we're thinking about how the different types of permissions and activity streams and modes will work together in spatial computing in the future. So let's all jump forward by about like 15 years, and we've all got glasses on, and I'm wearing like my, I don't know what brand I'm going to go with. I'm going to wear my Google glasses maybe, and you're wearing like a HoloLens, and you're wearing a Magic Leap device or a Meta device or whatever. Okay, so we're all in the future, and we're all kind of surrounded by our apps and information. Okay, so what do the computers need to know? What does the internet need to know? What do other people need to know? What do other devices need to know about you? What is this shared layer of things that we all need to know? First is permissions. And the cool thing about this is that right now permissions are pretty much just tied to the individual. My permissions are based on everything about me. This adds another dimension to permissions that is a literal dimension out into physical, spatial volumes. So there'll be public spaces, controlled spaces, intimate spaces, and then private spaces, which again is pretty much just tied to you. So let's go through these. The public space. This is, when you're walking down the street, stuff that's owned by the government. What does this look like? This could be the nightmares dystopia, of Times Square everywhere, the horrible, you're going to need an ad blocker. This future could suck. Obviously, it's going to have to be filtered. We might have to have many filters. And I think it's a little pressing of Apple that they've already banned ads for augmented reality. To me, that's probably the biggest sign that they're really bullish on the future of augmented reality, that they're like, let's just not even touch ads until we figure this whole thing out. But this space also has the biggest potential to be the most beautiful and interesting and best of humanity as well. Like, imagine that, we live in a world that can be as beautiful as we want it to be. So in that sense, the public space has a lot of advantages as well. Controlled spaces, which is about where we spend, 80% of our time, I would say. These are semi-public spaces that are either commercially owned or owned by individuals. There's a really big question around what you can limit people doing in your controlled space. And a lot of this, again, going back to these are things we don't have to articulate. If I walk into a Microsoft store, I can check my Apple email, right, today. That's really tied to me, and I've made that decision. But could I don't know, put up an Apple logo? No. We know that. We don't have to say it. But you could, in theory, with digital objects, do a lot of this stuff much more easily. So then Microsoft will have to say, no one can put any logos up, but our logo's in this store. Come on, you guys. You know, like a lot of the unspoken social norms will probably immediately be broken by all of the trolls. You know they're going to go try this. So we're going to have to rethink and articulate a lot of what we think of as just kind of standard behavior today. In controlled spaces too, obviously, in my dream of the future, we don't have to, you know, we'll have like a much better video conferencing system at last. That's all AR, so the IT guys will have a field day for that. Okay. Personal spaces, the apartments, homes, your car, your farms, your ranches. I was just in Nebraska going home for my class reunion and going by just wide, huge parcels of land that are all privately owned. I forget about that living in the city. So right now we have ads in our home all the time. And I would actually argue we live in a time where we have less ads than ever before. And certainly they're a lot more controlled, right? So back in the day, if I was listening to the radio in the 1930s, there would be ads playing and I couldn't do anything about it except for turn down the volume. Now I can skip most of the ads that I do see on YouTube after 5 seconds. But obviously when it comes to augmented reality, we've all seen those dystopian futures where there's ads all over your house and it's sort of become a semi-commercial space. So you have to think about how you let ads in at what time. If you block every ad in your home, then you get the sorry state of journalism today, for example, if there's no ad revenue. People will want to personalize the UI specifically in their home, the same way they want to personalize everything else about your home. So we're going to need a way to clearly delineate what types of digital objects can be moved by the user and how and when and on what OS, or do we standardize that across the board? What does that look like? And then also clear boundaries and uses of rooms. And I feel bad for every teenager in this era, right? You know, they want to put up what they wanted in their room, but what if their parents like, no, never mind, go back to default? Like, there's a lot of self-expression that goes on in how you design for your home that's, again, going to have to be clearly articulated between people who would otherwise just let their kid, you know, put up a bunch of posters. Like, now you're going to have a conversation around it. And then finally, the individual. And this one is interesting in that, again, it's not exactly tied to a place. It is tied to you. So things like your email, your diary, your finances, your porn, your dating, your health information, job information, all of that stuff, all of the things that you know about yourself and you may or may not want other people to know about you. And I think these we can pretty safely say are the top tier permissions that regardless of wherever you are, in whichever type of space you are, whatever your defaults are for these things, these are the things that kind of outweigh all of the others. The individual stands above all of the spaces. The other thing about this is that it requires you to give permission to other people. And this can be, again, a thing that you might not articulate. If I have a piece of art in my home, anyone who walks in my home can see this piece of art, right? But if I have a piece of art that's just my piece of art, it's just a thing for me, and maybe no one would ever see it, and then I want to share it someday, and someone's like, are you kidding me? You've been walking around with this? I didn't know this. Like, we're going to have these realities that mix but aren't exactly aligned. And you can do some really crazy stuff at this level, some of which could be terrifying. Like, for example, I decided that I want everyone to be in Star Wars today. Like, you're all stormtroopers. Here we are. This is great. You know, this is my theme. But that sounds cute, right? Like, oh, I turned you all into stormtroopers. Now you're a stormtrooper. What if I decided that I wanted you all to be naked? What if I decided I wanted you all to be the same gender or the same race? Or I just decided I didn't like the clothes you were wearing and I wanted to change that as well. All of these things, some of these seem really benign and just kind of cute, and some of them seem scary as hell, right? But if the individual can do whatever they want to the world, we are going to have to deal with the fact that some people want the world to be different in a scary way. And so there's a question there around what are individual rights and where does that end? Right now, when it comes to free speech, it goes about as far as here. You can say anything you want in this distance between you and me, but as soon as it starts to hurt me, then I can sue you for libel or slander or abuse or whatever it is, right? It's not a clear line, but it's a line that we can all recognize. And we're going to need to extend this to things like this. How much does the individual have the ability to change what they want to see about the world, even if they're the only person who can see it? Heavy stuff. Okay, now on to interactive states. I bring this up in part because I want to start a conversation around how apps and experiences will be in spatial computing. So this is what we've got for now, and I would love to hear more about how people are thinking of articulating this. So right now we're thinking about them active, semi-active, remote, and minimized, and I'll go through these as well. So if apps are active, they are maximum interactivity. I have my Netflix app on my wall, and I'm interacting with it. I'm hitting the fast forward button. I'm interacting with Netflix. Funnily enough, something could be minimized but still be fully active if I'm hitting like next, on a music playing app, for example. I'm interacting with it, but it's behind my ear or wherever it is. It will also need substates for multiplayer and multi-interactivity levels. So again, we're sitting there watching HBO. We're facing the same direction. Both of our apps are pinned to the same location, but I'm browsing and you're watching, right? So different states of the same app at the same time that's being shared concurrently with multiple users. Semi-active. So this is something we call internally progressive disclosure. Effectively, we assume that most apps you're not going to want to have on and around you all the time. And by the way, feel free, Unity makes apps. Feel free to sub in websites or URLs or however you're thinking about this particular paradigm. The digital content that you're interacting with. If it's semi-active, it's sort of aware that you are probably going to interact with it, and it has changed state as a result. So it's gone from being, say, minimized to being sort of semi-transparent, starting to light up, starting to go towards you. This one is, I think, really key in order to not feel like things are just hitting you in the head visually all the time. If you've ever been in virtual reality and had an app that didn't have good animation cycles or didn't scale in and out nicely, if something instantly appears in front of you, it feels very strange. It feels very wrong. It almost feels like some weird sense of a physical attack. Remote. This is basically like some subset of the app that is around. So if I have like a thermostat app, the thermostat's over there and the UI is attached to the thermostat, but I want to have a remote version that's a smaller version, something that's part of that larger app, and maybe could even go back to that app, back and forth, but I'm only working with a subset at a time. And then minimized. It needs to be discoverable, right? If an app is minimized but put it in a specific location, you can anchor it anywhere. We'll talk about location anchoring in a little bit. And it can't take up a lot of visual room, but we do need to be able to discover it. And this is a tricky issue, too. And we've done some prototypes and work around how you could discover something in sort of a pleasant hue, color at the corner of your eye kind of way. But there are a lot of different ways that you could discover things that are around you, but not something you're interacting with. This also begs the question, do we need an inventory, right? Like if I left my Word doc app in my house, I need to be able to pull it up from anywhere. So we need some sort of sense of an inventory equivalent for all the spatial computing apps that we'll be using. And then finally, the diamonds of location. This will make more sense why I called it diamonds in a second. All of the things and all of the states and permissions that I just mentioned also have a quality of where they are in the world. So they can be anchored to the world. They could be anchored to an object. There could be a GIF attached to this crystal geyser bottle, for example. They can be in transition, so you're interacting with an object by moving it, but you are not interacting with it fully. And then stuff that's just anchored to you that you pull up anytime you want. So as a matrix, these are the different apps, states, permission levels, and spatial positions. And this is kind of the system that we have come up with and are using internally. Again, this isn't set in stone. This is just a thing that we are using so that we can give developers the ability to say, here is the active state for my app, and here is the minimized state for my app. Let's test those both out and see what they look like when they're anchored to a user or to the world. When it goes from minimized to active, it needs to move away from the user at, a meter, for example. These are really, they sound a little esoteric, but they're really practical, frankly. This is stuff that we need to be building or are building into Project Mars, actually. Now. So again, so this is Project Mars today. We'll have the ability to go through and preview all of these different states and see what it looks like when you anchor different digital objects to different devices. But I'm really eager to talk to the community about how we can nail this, because I think this is a really important conversation. These are equivalent of pseudo classes, right? A lot of this stuff, or activity states. And I think this is something that we should try to work together as people who work in technology about building out the future and the states in the way that we think are important for users to be able to have. So holistically, what we're thinking overall, how we design these things, the states, the modalities, they directly affect what people do with computers and what they think they can do with computers. Especially with spatial computing, we have to have an incredible variety of modalities because the way people interact with the world is so vastly different. So rather than box the users in, let's support the users however they want to interact. That is the key. So, all right, we're all in this together. Thank you very much.
Thank you so much, Timoni.
That is amazing.
Orange. So we have about 10 minutes, a little more than 10 minutes for Q&A. We got a couple over the transom. I want to throw it out to the room right here first to see if anybody in the room has a question to kick us off. One question.
I'm super curious about the tension between kind of this heavyweight authoring and then the user experience, which seems like it's also kind of a lightweight authoring, or kind of like it seems like the worlds are separated right now. And are they going to come together? Or is there just going to be one AR desktop or something like that?
Yeah, I think they will come together. We're actually going to be starting on what we're calling on-device tooling, which is a fancy way of saying, you know, on a mobile app or on a HoloLens or on a Magic Leap device. One big thing that came up when we were doing Editor XR is that a lot of stuff is just words, and like a lot of complicated things right now in any 3D app or interactivity app you can name are a bunch of words in a dropdown, and there is no visual equivalent. For example, we had to kind of come up with a new icon for duplicate, because there is no icon for duplicate. There's an icon for copy paste, not for duplicate. So we're like, all right, we're gonna have to make this shit up. So I think as mixed reality authoring becomes more ubiquitous and more common and more standardized, and we think about it the same way and we express it the same way, it'll be easier for consumers to make it the same way. In the same sense that, you know, like you couldn't write a word processor, but you can type in a word processor and make a doc. So I think we're just going to need to make sure that the technical side is sound, and then we can start extrapolating that out to an easy way to think about interactivity in the world. Like I think a lot about how we're going to have objects in your game that you say that users can move and objects that they can't move. And then how do we create a visual language to show users what they can move and can't move? That's a new paradigm. People are going to have to get used to it. They get used to everything, you know, like minimizing windows. So we had to get used to that. So I'm not afraid that people won't get it. It's just making it ubiquitous, right?
Okay, from Slack, we got a question. Have you considered spatial analytics for XR in Unity? So analytics and the ability, for example, the ability to track or measure physical inputs like headset gaze, controller movement, player body location.
Yep. Yes, we did. We actually built some prototypes. I can tell you that the early tests just didn't show anything particularly useful. We should expand it out. So yes, it should be coming. But every time we did like a heat map of what people looked at, they looked at exactly what you thought they would look at. Like, oh, there's a zombie coming. Shoot, 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 shoot. You know, like it was just, maybe it's just because, you know, VR games today tend to be fairly single task oriented. So it's either like they looked at a bunch of UI and then they did the thing, and then they looked at the UI and did the thing. It just hasn't been like any kind of information that was worth like really. It was nothing surprising, I guess. That's it.
All right, I see a hand raised in this room. Reminder to the other offices, we'll call out for you if you have questions as well after this. Oh, I don't want to throw this. All right, ready?
I'm sure just for expediency in this talk, there was a dimension that you probably spent a lot of time looking at, but we didn't get to talk about. I was wondering if I could ask you to talk about perceptibility. So, you know, Project Mars, the system's going to have to make decisions about where to put things, but surely an important component of that is whether or not the user's going to be able to see it.
Yeah.
And surely for all the things that we care about here in this building, whether or not text is readable, whether or not audio is hearable, all that sort of thing. So could you talk a little bit about the dimensions of perceptibility that you guys have been looking at, and what sort of the biggest pitfalls are that you're worried are coming?
Can I just want to dig into that for a second. Do you mean in terms of accessibility, or do you mean in terms of sheer, like, humans just don't see stuff if they're not? Yeah.
The second, the latter.
Okay, cool. Yes. So
I'm gonna see.
yeah, sure. One really funny thing too about virtual reality is, I guess this kind of invalidates what I said earlier about the analytics, but two sides of the same coin. People just, like, you can have a big arrow right here that's like, look at me, and people are like, I'm looking over here, you know? And that's where I really think audio comes in and is key. And audio is, I love audio because it is, you cannot opt out of audio unless you turn off your phone. That's a whole different thing. But as long as the sound can hit your ears, unlike closing your eyes, you cannot close your ears, you will be able to hear it. And while in front of your face, you tend to be a little imprecise about where the audio is coming from. If it's behind you, you are actually much more precise, which is really cool. So when it comes to getting people to see the things that you want them to see, that's actually why I talk a lot about modalities. Like, don't limit it to visual. If you have something behind someone and you make it sound like an explosion, they will turn around. They will absolutely turn around. So if that's what you want them to do, go heavy on the audio, as long as they can't opt out. And again, it's kind of a shame because right now we have so many beautiful audio engineers making all of this beautiful audio feedback for all of these apps, and I just never have my phone sound turned on. But we can imagine in the future, you know, if it's limited to you, you know, if you've got your AirPods in or whatever, then you'll probably opt into the sound more.
To clarify, a concrete example that I'm very concerned about is that being able to utilize a mixed reality environment in some place that's perhaps dangerous, like a factory.
Oh, right.
And I need to be sure that if there's a danger marker, if there's a sign, that is not just visible, but also legible. Just so, because in the real world, I can guarantee that through iteration as I put it up, but if a system like Project Mars is going to make those decisions for me, how do I make those guarantees? What are the sort of dimensions that I need to be concerned about in that environment?
I think that would go under the permissions layer. Like, I like this. Okay, good. I've been trying to come up with good arguments where the individual settings should be able to be overwritten, and I think that's a great example where if I'm in a semi-commercial or a semi-controlled space and they have a big warning, "Don't come in here" sign, then yeah, like obviously that should override any individual options I have here. There's going to be some interesting government regulation around that, I think. I'm going to say no, we have not thought about it in that way. We're trying to get text more legible. Text Mesh Pro integration has been going really well. But I think that's an interesting point. But it does seem to fall more under permissions than creation, just from that example. But making sure people could see things in any language, for example, that's kind of a cool benefit, I suppose, of augmented reality. But I think, too, we're not going to get rid of the physical entirely. If anything, maybe you'd have a big sign there, but then you can also attach an AR object, and the AR object translates what's on the sign. That's great. That's a great perspective, though. Thank you.
Any of the other offices want to ask a question in the mic? Give you a couple seconds. All right. You can also Slack it in speaker series. So another question that did come through was, since you're probably one of the people with the most experience in XR authoring, how did authoring in XR change your own worldview outside of XR?
I notice how much more people mess up all the time. So when the trend in design, in digital design, has long, I would say at least 10 years now, been for simplicity, to put the content first, start from an information architecture perspective, add in animations, but to really, get rid of the skeuomorphic and kind of just parse away everything that needs to be done. I think this is part of the economics of, an app has to nail that one thing in order to scale, yada, yada, but that's just sort of been the metric. And so there are very specific flows that are designed to be incredibly unforgiving unless that user hits whatever KPI that you put in front of them, right? Like they got to the login screen, or they hit the like button, or whatever it is that you want them to do. The reality of how people use computers is that they are continually tapping on the wrong thing, accidentally closing stuff, hitting, 5 pixels off, hitting the wrong key. Like, people just constantly mess up with their computers. And when we started working on especially editor XR, people would just mess up all the time. And I felt like, well, fuck, we're just doing this all wrong. People are messing up all the time. This is terrible. And then as I started to think about how people use the computers that you probably have used every day for 8 hours of your life for the last, 8 to 12 to 20 years, I was like, I think it's a little bit more that people get used to messing up, and the software gets really good at being forgiving when you do mess up. So that's probably the biggest change in perception.
Okay, we have time for about one more. If anyone, we have nothing else. I see a hand. All right. Ready?
Awesome.
That is so cool.
Yeah, so I love the talk. A lot of what you've said seems really well thought out, and you've gone through all the use cases and scenarios. Are there any problems right now that you're still faced with and don't have a solution for, and you're just stuck with that you need solving?
I need a headset, guys. Like, we're so ready. We want the hardware to be there, and that's such a bigger challenge. We know it. I guess there's a couple of things. We'd like the world data to be more standardized across the board, but it's like, these are the titans of the tech industry, and they're like, we can consistently find a plane. We found this one plane. Put your Thomas Tank Engine app or your, dragon, little pet dragon, or your piece of art or whatever, put it on that one plane. And that's about extent of what you can reliably get without extremely customized hardware. So I think, on my team, we were all just imagining a future, and we've all worked in virtual reality long enough to know that, it's not going to be quite what we expected. The controllers will be different. There'll be weird quirks we weren't expecting, but we all just really want to get this party started. That's probably the biggest thing.
All right, well, that's a wrap. So
Okay.
Thank you so much.
Yes, thank you.